Good evening, friends. So today we are going to discuss about development of surfaces problems. So development of surfaces. Development of surfaces means unfolding or unrolling the objects. Unfolding and unrolling the objects. Unfolding and unrolling the object. So assume that hollow and made up of the thin sheet. So it will be cut and open it from one side and unfold the sheet completely. Then the shape of that unfolded sheet is called as the development of lateral surfaces. For example, cone and prism, it will be pyramids and pyramids, it will be unfolding. If in case of cone and cylinder, it will be unrolling. Development of surfaces means unfolding and unrolling of the solids. Assuming that a hollow and made up of a thin sheet, it will be cut and it open from one side. Just unfold the sheet completely, then the shape of that unfolded sheet is called as a development of lateral surfaces of the object or solid. So engineering applications, there are so many applications. So there are so many products or objects which are difficult to manufacture by conventional manufacturing process because of their shapes and size. So those are fabricated in sheet metal industry by using development techniques. So there is a vast range of such objects. So the best example in the development of solids is sheet metal industry. Sheet metal industry will be using for this development of surfaces. So it will it's difficult to shape. It is difficult to say we have different shapes and sizes. So we are unfolding and unrolling of the object. That is the development. Unfolding or unrolling of the object. So that is about development. So these are a lot of examples. So here we have a boiler, a shell, chimney, pressure vessel, boxes, cartons, feeding hoppers, large pipe sections, body parts, automotive ships, aeroplane, and many more. So we are going to learn methods of the development of surface of different solids and their sections and frustums. So now we are going to see one by one. We are going to, so this is about a cylinder. So the circumference of the cylinder, the base diameter is 2 pi r or pi d. So this is about, the development of cylinder. Next we are coming to the prism. So this is about pentagonal prism. So this is the development of pentagonal prism, 5 into each side. So this is about cone, and we are going to see the development of cone also. The cone sector will be like this. Cone sector will be like this. Then this is about pyramid. The pyramid sector and the triangles will be appear like this. So this is the development of pyramid. This is the development of pyramids. Then this is about tetrahedron. Then we have a cube and 6 sides. The development will be in 6 sides. So this is about frustum. So now we are going to draw the pentagonal prism. So we are going to see the development of pentagonal prism. So 30 mm base side and 50 mm axis is standing on HP and its base, whose one side is perpendicular to VP. So it is cut by a section plane 45 degrees inclined to HP through the midpoint of axis. Draw the front view, sectional top view, and sectional side view, and also the true shape of the section. And we are going to discuss the development of surface of the remaining solid. So we are skipping someone and we are mainly focusing on the development of surface, right? So the axis is perpendicular to HP. So that means the pentagonal prism is resting on HP. So when we are seeing from the top, the base will be appeared. So the base pentagonal shape will be drawn in the top view and prism. So the rectangle will be appear in the front view. So first we need to draw the reference line and we need to draw the top view pentagonal base in the top view and we are going to draw the rectangle in the front view. After that, so it is cut by a section plane 45 degrees inclined to HP. So the section plane cutting 45 degrees to the axis and through the midpoint of the axis. Now we are going to draw the development, sectional top view, true shape, and side view. So one by one we are going to see. So this is my reference plane, XY reference line. So we are going to draw the pentagon in the top view. So this is about pentagon in the top view. You have to name it A, B, C, D. Then we need to draw the front view, that is about rectangle in the front view. So you have to name it all the. Then this is about a section plane. A sectional plane, it is cut by a section plane 45 degrees inclined to the HP. So this is about the sectional plane. So it is cut by a section plane 45 degrees inclined to HP through the midpoint of axis. The axis height will be 50 mm. So this is about midpoint of the axis. This is about midpoint of the axis. Right. So this is about our stage 1 diagram. This is about base diagram. So we need to draw the base and we need to base in the top view and rectangle in the front view. Now we are going to see the front view, sectional top view, side view, and true shape, development of surfaces. So this is about side view. Now coming to the true shape. So this is about sectional top view. So this is about sectional top view. So this is about sectional top view. Now we are going to draw the true shape. So draw XY to section plane, draw projection arms from draw projectors on it from cut points. So mark the distance of points of section part from the sectional top view and the above projection frames. So this is about exactly parallel to the cutting plane. This XY, another dummy XY reference line is exactly parallel to the cutting plane. You need to draw the exactly parallel to the cutting plane and you need to project all the generators. So where the cutting plane is cuts that. So from that point, we need to project exactly perpendicular to the cutting plane. Then you need to mark these points from this point to this point and this point to this point. As accurately you have to measure and mark on these points and join all these points and you will get true shape. Join all the points with the lines. Finally, you will get true shape of the pentagonal prism. Then hatching will be done. Up to here, this is about true shape. So this is about side view. Then this is about sectional top view. Now one more, it is development of surface. Development means unfolding of the object. So this is about a cylinder, pentagonal prism. This is about pentagonal prism. Prism. The 5 sides, 5 into base diameter, 5 into base diameter, that is about 5 into 30. That will be 5 into 30, 150 mm. So you need to draw the 150 mm line. For development, draw the development of entire solid, name from the cut open edge, that is an A. So in the sequence as shown, mark under the cut points on the respective edges, join them in the sequence on it. Lines mark existing it will be given the development. So you need to draw the 5 rectangles. So we have a 5 pentagon. It has 5 sides. So we need to draw the 5 pentagons. 1, 2, 3, 4, 5. So name it A, B, C, D. Again, A. So you need to join all the vertical lines where it will be cutting. For example, A to A. So you need to draw first you need to join all the vertical lines. You have to draw all horizontal lines from the cutting plane where this section plane cuts this axis of the prism. So you need to project from horizontally. Now you need to mark on that points. So A, this is about A, and coming So this is about B and E point, and this is about C and D. This about C and D. We already done the E, and again A. Now you have to join all the points with the lines. Right? Then you have to tick this shape also, this point, and you have to tick this with the help of two HB pencil. You need to draw tick this one also. So this is about development of pentagonal prism. In this way, we are going to draw the development of pentagonal pyramid. So this is about the entire development of this pentagonal prism. I hope you are understanding the development of pentagonal prism. Now we are going to draw the cone, development of cone. So cone diameter base is 50 diameter. So that is about radius is 25 mm radius, and base diameter is 70 mm. 70 mm axis standing and base on HP. It is cut by a section plate 45 degrees inclined to HP through the base end of base end. The condition will be different here. It is cut by a section plate 45 degrees inclined to the HP to the base end of the end generator. Draw the projection of sectional views. So in the same manner, we are going to draw the development of cone here. So first we need to draw the 50 mm base diameter. Then we need to, in the front view, triangle will be appear. Before that, this circle will be divided into 8 equal parts, and you have to name all the 8 parts. Then you need to project the axis, and you need to draw the triangle in the front view. So this is about stage 1 will be completed here. Stage 1 is completed here. Now we need to draw the, it is cut by section plane 45 degrees inclined to the HP, base end of the end generator. Base end of the end generator. So you have to draw all the generators. Name it all the generators. A dash, B dash, H dash, C dash, G dash, D dash, F dash, and E dash. So this is about O dash. So this is about side view. Now you have to cut the end generator. Now you have to cut the, so this section plane 45 degrees inclined to HP through the base end of the end generator. Base end of the end generator. So you may take either side. So this is about base end of the end generator. Base end of the end generator. The inclination will be 45 degrees. Base end of the end generator. Right? We need to project all the where the points will be cutting. So this for finding the sectional top view and true shape. So you need to mark all the points. This is about sectional top view. Sectional top view is just now sectional top view is completed. Now we need to draw the true shape. So we have to draw the one more reference line that exactly parallel to this cutting plane. Then you need to project all the lines, all the generators exactly perpendicular. Then you need to mark, or simply, so this XY reference is AE line, and you need to mark, take the compass and mark this point, and mark all the points. You will get, so this is about true shape. You will get this. So this is about true shape. So this is about sectional top view, this is about front view, and this is about sectional top, as a true shape of this object. Now we are moving to the development of surface. Now we are moving to the development of surfaces. So development of surface. In order to find the development angle, we need to find the theta equal to small r by capital R. Where small r equal to radius of the circle, based on radius of circle, and capital R equal to the slant edge radius. Take the compass and measure this radius. So this slant edge will be capital R, small r by capital R into 360 degrees. So then we need to find the angle. So the sector angle will be finding theta. Theta equal to small r by capital R into 360 degrees. So it may be angle 138 degrees. So that will be divided into 8 equal parts. That sector will be divided into 8 equal parts. Like that, you have to divide the 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. Like that, you have to given the names A, B, C, D, E, F, G, H, again A. Like that, you have to give in the names and you have to mark the points. Take the compass from O to OA generator. OA generator, you have to mark this point. And similarly, next O, B, and H generator. Take the compass and mark this OB and OH. After that, take the compass and mark O2 is CG dash. That point we call it as from this. You have to give in the another names P, Q. So this is about P, QR, P, Q, R, S, T, U. Like that, you have to give in the names and you have to mark the points with the help of compass. So first one is A, then H and B in the same points, HB, then CG, C point, G point will be on the same. CG, after that, CG, then we have to mark this point F and D. Now F and D, F point and D point. And then final point, we have E point. So this is E point. Take O2, this point, and mark in this sector. Now you have to join. You have to join all the points with the smooth curve. So this is about development of surfaces. Development of surface of the cone. Development of surface of the cone. So in this way, we are going to develop the cone, a cylinder, prism, whatever it may be. So this is about the development of cone. So this is about hexagonal prism. So these are the different types of different developments. So these are the development of surfaces. For cylinder, we are going to get like this. The development will be like this, and this is about prism. We get like this. So just now we have seen the cone problem. So the cone sector will be like this. For example, pyramids, the development will be like this. I think you may understand the concept of development of surfaces. Thank you.